Hello, welcome to Vendia Traceability for Secure Supply Chain demo. Let's start with the challenge. Semiconductor manufacturing is a very complex process. The 10 activities that you see listed here is an oversimplified version of a die fabrication process. The data generated in these 10 steps lives in multiple organizations, systems, and departments. If we can figure out a way to bring this data together in one place in a secure and private way, we can solve very interesting use cases. One such use case that we want to demonstrate is tracing a fault in a die through a production process. We also call it die genealogy. Based on our customer conversations, we have identified 4 key requirements for building such a system. Ability to track product journey from start to end. Do it by bringing in right information without exposing the IP of the partners. System should be strongly auditable, and the single source of the truth of die traceability data should be immutable. With these requirements in mind, we propose building secure private data exchange for die traceability using Vendia distributed serverless technology. Distributed ledger is the same technology or the database that powers blockchain applications. Let us try to unpack this solution architecture diagram from left to right. The die traceability data lives in internal systems such as MES, ERP, and Historian. From these systems, we will source attributes like batch ID, lot ID. We can source it in clear text format, or we can further anonymize it before we bring it into Vendia Share distributed ledger. When we have identified the sources of information and the attributes, we can bring them into Vendia distributed ledger to start data sharing with control. The way it works is that every organization gets a node, and when organizations write data into Vendia distributed ledger, they annotate the permissions at the record level. Once the data is written by individual organization, Vendia will start their application process, looking at the authorizations provided for data sharing at the record level. Eventually, what will happen is every node will get a read-only copy of the full traceability data from different organizations. Once the data is there, either we can do ad hoc querying on the node itself, or we can export it to the private cloud for further analytics and visualization. Let's switch to the real demo now. For the purpose of visualization, I'm using a tool called Tomsware software. This tool is connected to the data that we just sourced from 3 different organization internal systems that we brought into the Vendia Share data exchange. I'm going to run a very simple scenario where 2 dies have been reported faulty, and I want to backtrack their journey. The 2 dies that were reported faulty are die number 1 here and die number 2 here. Let me execute this query and try to pull up final testing event for these die. If I want further details about the testing event, I can click on it, and on the left-hand side, I will be able to see the metadata related to the testing event for that die. I can do the same for the other die. Let me start backtracking and try to basically find out the full journey as it started from the sales order for this particular die. Here, I'm trying to do things manually, but you don't have to do it. It can all be done programmatically in one single query. So finally, I'm able to backtrack it up to the sales order. Now let me try to trace the journey that this particular die here took back from the start of the sales order. I will tag this final testing event as the finish node, and this particular event as the start node. Run a find shortest path on this 2 nodes. You can see that the purple line highlights the full path starting from start to the finish node for this particular die that is associated with this final testing event. So we now know the journey that the die took starting from the sales order to the final testing event. Now we can do one more interesting thing. We had another testing event here. Let us try to repeat this same process for this second die, which was reported faulty. The information for that die is associated with this final testing event. Now you would see that something interesting happened. as I was backtracking this die, I could see that this particular die that I traced initially had an event here, which is the wafer sorting event. And this particular die number 2 that I was trying to backtrack also converges or intersects with the first one at the same event or the same step in the process. Let me try to show it in a different view. You can see that this die backtracks to this event, and this die also backtracks to this event here. It is possible, and there is a likelihood that most of the faulty dies resulted because there was something wrong in this particular step in the production process. And from here on, you can dig deeper into it using the existing methods you have to exchange data or to do the root cause analysis. This is the demo that I want to show. For questions, we are here at AWS booth.